someone next to you. We're going to look at two types of problems that use the proportions to solve them. We'll be using proportions on quite a few problems in this class, which is why we did the proportions last time. The first type of problems that we work using proportions are going to be a dosage type problem. These will be when I pick up a bottle and it says something like there's 2 milligrams of drug in 5 milliliters. These problems will always say in, per, or contains. And this will be what was going to be on the label of a bottle when we are giving drug dosages. So if I see 2 milligrams in 5 milliliters, oops, got a little carried away there. Whatever we see in the dosage, we write that down as a proportion. 2 milligrams in 5 milliliters. But you want to keep your labels. You want to keep your labels because that's the only way to know where to put the next part of the proportion. The next part of the proportion will say something like, give 6 milliliters. How much drug is given? So if it tells me to give 6 milliliters, and I have a label that says 2 milligrams in 5 milliliters, the label tells me milliliters to put milliliters on the bottom. And so many people think I can do this without the label. They leave off the label. Well, they'll get some of them right because they'll put 6 on the bottom. But without the label, you don't know if 6 goes on top or bottom, so you'll put the 6 on the wrong position. Always label these problems. 2 milligrams in 5 milliliters. If I have 6 milliliters, then whatever's missing is my X. Now when we go to do the arithmetic, we can ignore the labels. So I go 2 times 6 is 12 equals 5X. And if I divide by 5, what do I get when I divide by 5? It's 2.4. And also the labels up here tell me what to label my answer. If X is across from milligrams, my answer is going to be milligrams. Now these answers are going to be in decimals. That's because drug dosages are in the metric system. The metric system is always given in decimals. So you can use your calculator. Don't worry about the fractions. Just divide it out. All the drug dosages will give our answer in decimals. Okay, so now I want to look at the problems on page 10. And the first problem on page 10 says there are 3 milligrams of drug per ounce. 3 milligrams per ounce. How much drug is there in 5 ounces? Whenever we see the in, per, the contains, that becomes our first fraction of the proportion. And keep your label. Per ounce means for every 1 ounce, so I put 1 ounce. 3 milligrams per 1 ounce. Now, if I kept my label, I see that the 5 does belong on the bottom. So my X is here. 3 times 5 is 15. 1 times X is just X. All of these have to be labeled. And the X this time is milligrams. We can tell the X is milligrams because it's across from the milligrams. Now, these aren't very simple problems. Some of them you can almost just read and write down the answer. But get in the habit of writing your proportion so when you get to problems that you can't just glance at and tell what the answer is, you do know how to set it up. Whatever's the N per contains becomes a proportion. Keep your labels. I can't tell you how many people miss a problem just because they didn't label it. And you might save yourself 2 seconds, but you miss the whole problem. So keep up with your labels when you set the proportions. Okay. The second problem says a vial contains 0.4 milligrams in 5 milliliters. 0.4 milligrams in 5 milliliters. How much must be given if I want to give a dose of 0.6 milligrams? So whatever we see N per contains goes down as our first proportion. This time, because I wrote my label, I can see that the 0.6 milligrams goes across the top. If you match the labels, we see that the 0.6 goes on the top. So when I cross multiply, I have 0.4x, 5 times 0.6. What do you get when you multiply that on your calculator? 3. Then we take our 3 and divide it by 0.4. And you get, this time X is across from milliliters, so make sure you label it milliliters. Now, number 3 is a different type of problem. It says 50 milliliters of a 5% solution. The second type of problems we will look at tonight are solution problems. The first are dosage problems, and we recognize those because of the names N per contains. Solution problems, we'll recognize they're a solution problem because we either have a percent or a ratio. The percent or the ratio is the strength of the solution. These problems, we have to memorize a formula. And the formula says strength desired divided by strength on hand. The first part of the proportion is our two strengths. Strength desired is what you want to make. Strength on hand is what you have. Now, this should be one long formula here. I don't have room to write it. Strength desired divided by strength on hand is equal to amount on hand divided by amount desired. These problems are as simple to work as the other ones, but they're a little harder to set up because we have to memorize this formula. We have to memorize the formula to be able to set the problems up correctly. The first half is strength over strength. That equals amount over amount. But we have desired on top on the strengths, desired on bottom on the amounts. Some people memorize strength desired over strength on hand, amount on hand over amount desired. But that only helps you if you remember what they stand for. So as you write it, think to yourself, strength desired, strength on hand. This side has to be strength over strength, amount over amount on hand over amount desired. So I'm going to look at this problem number 3 and see how I can fit that into this equation. Number 3 says a graduate is just a solution, contains 50 milliliters of a 5% solution. How much 2% can be made? I want the strength desired. The strength desired is 2%. That's what I want to make. The desired is what you want to make. Now, what's the strength on hand? It's the other percent, 5%. Now it's the amount on hand. How much do I have? 50 milliliters. This time the labels match up and down. And the percent can be looked just as a label here. This time we don't have to change it to 0.2%. We can pretend that's just like a label. So to multiply, I go 2 times x equals 5 times 50. Now every other time we had to move it over and make it 0.05%. When we have a percent over a percent, pretend those just cancel each other out. You don't have to do anything with it. So when I divide by 2, I get 125. This time the labels match up and down, so it's 125 what? Milliliters. Now you have to memorize the formula. Once you've got the formula memorized, it's just as simple to work, but you have to know strength desired over strength on hand, amount on hand divided by amount desired. Now, one way when you set these up, you can check, is you can find the two numbers connected by the word of. Number 3 says 50 milliliters of 5%. 50 milliliters of 5%. The numbers of connected by the word of have to be on the diagonal from each other. So after you set it up, you can go back and look for the word of, 50 of 5, and make sure that 50 and 5 are on the diagonal. It's one way to make sure you didn't get something upside down if you always check your word of. The numbers on the of have to be on a diagonal. Okay, I'm going to try number 4. Four says 2 milliliters of a 20%. How much 5% can I make? So I always stop and think, strength desired, strength on hand. Amount on hand, amount desired. What's the strength that I want to make? Okay. What's the strength on hand? Now, 2 milliliters, is that on hand or what I want to make?
That's on hand.
2 is the on hand. Now, again, take just a second to check your of. If you check your of, you see that it's 2 milliliters of 20. Make sure 2 and 20 are on a diagonal. That's one way to check that you don't have it upside down. The of words have to be on a diagonal. So 5x is equal to 40. X is equal to 8. But I didn't label it. 8 milliliters. Number 5. Number 5 says make 250 milliliters of a 1 to 500 solution. It's another solution problem, but the solution is not given as a percent, it's given a ratio. So this time my solutions are going to be a ratio over a ratio. What do I want to make? I want to make 250 of a 1 to 500. What is the strength desired? The strength that I want to make is 1 over 500. What you want to make is the strength desired. So what's the strength on hand? Now, these always have to match up and down. If I have a fraction here, I have a fraction here. If I have a percent here, I have a percent here. So I have a fraction over a fraction. I want to make 250. The strength desired goes on bottom. Again, check your of words. 250 of 1 to 500. 250 of 1 to 500, 250 and 1 to 500 are on the X. If you ever get these upside down, as long as the right of words are on the X, you're still going to get the right answer. So I have 1 to 500 times 250 equals 1 to 100X. Now, since your answers are going to be decimals, if you want to, you can go ahead and take this as a decimal, or you can work it as a fraction. This is 250 over 1. 250 and 500 reduced to 1/2. Or again, if you wanted to, if you take a decimal and put 0.5, that's okay too. But now I'm going to take 1/2 and divide it by 1 over 100. You always divide by the number on X. The number on X is after the division. So that says to multiply times 1 over 1. So when you flipped it over, if you have a decimal, you could just take 0.5 times 100. Or 1/2 of 100 gives me 50 milliliters. That's going to work out all right as long as those divide equally. But if it's 1 over 300 and you change it to 0.033333, then you're going to be off in your final answer. If it comes out evenly, it's always okay to go to a decimal. Like down here, 1/2, I said it was okay to go to decimal. If that would have been 1/3, don't go to a decimal to your final answer. If it's even, it's okay to work with decimals, but if it's not, don't use a decimal to your final, or you're going to be off in your final answer every time you round and do more arithmetic. Okay, number 6. Number 6 says a vial, 8 grams of drug in 500 milliliters. This is not the solution type problem. We have to memorize the formula for the solution, but this says 8 grams in 500 milliliters. When we see N per contains, we write that down, but we keep our labels. How much drug is in 75 milliliters? So where does 75 go? The bottom, match, milliliters. 8 times 75 . 600 divided by 500 gives you 1.2, and what is it labeled this time? Grams. All of these problems will have to be labeled, and that's another reason to keep up with your label. Even if you get it right, you need the labels to know what your answer is.
So, but you guys, this is a proportion problem. It's like the first one.
Right.
All solution problems are proportion.
Right, because the N per contains, and because it doesn't have a percent or a ratio. Percent or ratio tell you have to use the formula. Percent or ratio tells you what you have to memorize that formula for. If it doesn't have a percent or ratio, then we can just write it down. The homework on these problems will be page 11. But if you look after that, there is also a Unit 1 review. Make sure you look at the Unit 1 review because our first major test is Monday. Make sure, as you're reviewing for the test, that you memorize your Roman numerals if you didn't. Most of you did all right on the quiz, but some of you had a little trouble. So make sure you look at your Roman numerals. There'll be fractions, converting fractions to decimals, percent problems, proportion problems, and the application we looked at tonight. I can tell you some of the things that are missed the most on the test. Remember to reduce fractions to lowest terms. Remember not to leave them as a mixed number. If you have 2/4, you have to write it 1/2. If you have 7/6, it has to go 1 1/6. You don't want to do the arithmetic right and then miss the answer because you left it 2/4 or you missed it 7/6. So the first thing to remember is to make sure you reduce your fractions. Next thing to remember is 0 in front of your decimal. Just as you do your homework practice, make sure you remember to always put a 0 in front of the decimal. Another problem, let's see, that will give you trouble is going to be like on page 13, number 27. This was where we had the ratio that had a fraction in it. This problem, when you multiplied the outside, you multiply 1/2 times 36. If you need to, write it down, do the arithmetic. But what is 1/2 of 36? Equals 1/4 x. The outside is 1/2 times 36 equals 1/4 x. Then it's 18 divided by 1/4 You always divide by the number on X. The number on X is after the division. So it's 18 times 4 over 1, 72. And also make sure that you've memorized the formula for the problems that have a percent or a ratio. The formula that we just went over tonight. Mm-hmm. I'm sorry? Oh. Now, if you have your books with you, I want to look just a minute on page 53. On page 53, these are the answers on the Unit 1 review, number 13. That answer should be 1 and 11/21. When I typed it in, I just got those numbers reversed. So on page 53, Unit 1 review, number 13 should be 1 and 11/21. I have 11/12. Page 53 is the answers in the back, and on these answers, I have one of them typed in wrong. This is the correct answer here. Okay? Any questions? And Monday, I will answer questions. Then you will take the test. Monday, as soon as you turn in the test, you are free to go. Okay? We'll see you Monday then.